Before we can perform histological analysis, bone samples have to be prepared accordingly. In short, samples approximately 1 to 2 centimeters big need to be clean and dry. Clean and dry samples are embedded in resin so that they are not damaged during cutting. Once the resin is dry, samples are cut with a saw to a thickness of 60 to 100 micrometers, depending on the preservation state. For example, fragile bones, such as cremated, are best left a bit thicker and then thinned later with grinding. It is best to cut the samples with a slow diamond saw equipped with cooling system which prevents overheating and damage. For each sample, around 5 sections are recommended in order to have more in case some damage occurs during later steps or if the structure is not well visible. Sections are then mounted onto the glass slices, grinded with abrasive paper and polished until the bone structure is well visible under the microscope. For protections, samples are covered with glass cover slips. Once prepared, samples are ready for observation and analysis under the microscope, usually using 100 to 400 magnification. One of the first questions that we need to answer is if the bone is human or animal. Though if the bone is macroscopically well preserved, this might not be an issue, but a lot of times preservation is too poor to be sure. For example, in cremations or when only a small fragment of bone is preserved. Human bones have different growth patterns, nutritional requirements, and are subjected to different mechanical strain compared to animal bones. Differences depend on species. Among mammals, marsupials, insectivores, bats, and rodents differ most, as they lack secondary haversian bone. Other mammals have haversian bone, but is organized differently. Differences in structure are based on stratification, longitudinal, perpendicular, or radial vascularization, regular or irregular cross-sections of vessels, and osteon types. Most obvious differences are in haversian canals, mainly in their number and size. Small mammals don't have osteons, while larger mammals have osteons but are on average smaller than in humans. Usually they are smaller than 40 micrometers, while in humans they are around 60 micrometers big. And let's have a look at some examples. On the left, there is a sample of a human bone under normal and polarized light. On the right, there are samples of horse, cattle, and sheep. The latter is under normal and polarized light. There is a clear difference in the organization and size of the osteons. In human bone, osteons are randomly organized and are bigger when compared to animal bones. They are also more circular, while in animal bones, the osteons are organized in lines and have a more ellipsoidal form. Again, on the left, there is a sample of human bone and on the right of a sheep bone. Again, a clear difference in the structure of the bone and in the organization and size of osteons is seen. In the sheep bone, a haversian bone is seen on the endosteal side and a plexiform bone on the periosteal side. In third case, on the left, there is a sample of human bone and on the right of a dog bone. The latter has osteons linearly arranged with osteon binding. Difference between the organization and the size of the osteons is clearly seen.